people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination, and they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system, but this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Move over, Star Wars. Astronomers have discovered an exotic star system that puts you to shame. Did you know our solar system is a bit of a loner in the galaxy? Most stars actually have companions, and some even have multiple. For example, binary star systems are very common, consisting of two stars orbiting around a common center of mass. Usually, you can't see them with a naked eye. To an observer on Earth, they'll most likely mold together and appear to be one. For example, Alpha Centauri A and Alpha Centauri B together form a binary system. They're some of the brightest stars in their constellation and the third brightest in the night sky in general, outshined only by Sirius and Canopus. But if you look at them, they'll appear to be a single star. Although it's not always like this. There are also so-called double stars. They're located so close that they may seem like a binary system, and they can either be one or not. You can even do a little eye test. In the Big Dipper constellation, try to look for Mizar and Alcor. They're kind of hard to spot, but they're right there on the arm of the Big Dipper. Now, if you're able to see them not as one, but two, then you have good eyesight. And hey, why settle for just 2 stars when you can have more? Triple systems are also quite common, with 3 stars orbiting around each other in a delicate cosmic dance. These systems can be full of surprises because the orbits are so difficult to predict. But all this pales in comparison with the recent discovery. A few years ago, a team of researchers discovered an actual 5-star solar system. It's located 250 light-years away in the Ursa Major constellation and was discovered by the Super WASP project. All of the stars there were formed from the same disk of dust and gas, and now they're connected in one complex gravitational dance. Now, this doesn't mean they're all incredibly close to each other. They don't do some kind of a square dance, you know. In fact, they're separated by more than the distance of Pluto's orbit around the Sun. Usually, such large systems consist of smaller ones. For example, in this case, there are 2 stars that are super far away, 2 stars that are so close that one is practically stealing the other's hydrogen, you bad boy, and one tag-along lone companion. But they all orbit around a common center of gravity. With all these interactions, it's a wonder they don't collide and create one big bright mess in the sky. But it's not surprising that each such system is more complex and rarer than the previous one. And this all raises the question, what kind of unique environments could exist in such systems? What would our life look like if we lived there? Well, let's see. Picture this. You're on a planet orbiting one of the stars in a quintuple system. It's a sunny day, and you're ready to hit the beach. As you step out of your space house, you look up at the sky and see not 1, not 2, but 5 suns shining bright like diamonds. 2 of them are super close together, almost as if they were one. Then you see the other pair, a bit further apart, each with their own glow. And finally, the loner star in the corner, just doing its own thing. It's overwhelming, to say the least. Now, you might be wondering, but what would the day-night cycle and changing of seasons look like on such a planet? Well, here things might get a little complicated. Depending on the orbits of the stars, the planet could experience pretty random daylight and darkness hours. They can even be constant or last for very long periods of time. All depends on the location of the planet. If we lived in a binary star system, things would be easier. There would be 2 distinct periods of day and night as the planet orbits around the 2 stars. But with 5 stars, their brightness and position would be constantly changing, so the day-night cycle could get extremely chaotic. Hey, I need my sleep here. On the other hand, this would make for some pretty spectacular views. We could experience several different sunrises and sunsets, each of different brightness and color per day. The changing of seasons doesn't get easier. You know how on Earth we have 4 seasons caused by the tilt of our planet's axis in relation to the Sun? Well, in a 5-star system, the locations of the stars could drive our planet insane. It's like having multiple chefs in the kitchen, all trying to cook different dishes at the same time. For example, if we're closer to star A, we experience more summer-like conditions. If we're closer to star B, things will be more chilly and wintry. And if we're located somewhere in the middle, we'll experience both summer and winter at the same time. It's like trying to juggle multiple balls at once. And this is a super simplified explanation. There are also things like the planet's orbital path, the tilt of its axis, the gravitational pull, yada yada. In short, the weather forecast will now become 10 times more unreliable. I'd hate to be the weather person on TV. That's a no-win scenario. And if that's not enough, then how about a roller coaster of radiation? The nasty solar winds and heat from multiple stars could make the conditions on our planet super harsh, rendering it uninhabitable. For example, if you're unlucky enough to live too close to the binary pair of stars, you'll feel like you're constantly stuck in a microwave. But hey, at least you wouldn't have to go to the tanning salon. And if you're too far away from the stars, it would be like living in an eternal winter wonderland. And if you're somewhere in the middle, well, imagine living in a place where you can get sunburn and frostbite on the same day. And this is just the beginning. You see, with 5 stars in the mix, there's a whole lot of gravity to go around. That's like being in a group hug with some really strong and clingy friends. The gravitational forces from the stars could tug and pull at the planet, creating tides so strong they could wash away entire cities. And don't even get me started on the earthquakes. With all that gravity, the ground beneath our feet would feel like it's constantly shaking, rattling, and rolling. On the bright side, though, at least we'd always have an excuse for being late to work. Sorry boss, I got caught in a gravity wave and ended up on the other side of the planet. You're not buying that, are you? As you can see, we'd have to try hard to adapt to such a system. All this, obviously, would create some challenges for agriculture. With multiple stars in the sky, plants would have to adapt to receiving light from different angles and intensities throughout the day. Farmers might need to create something to protect crops from excess heat and radiation. On the other hand, having multiple sources of energy from the stars is pretty awesome. Imagine fields of solar panels soaking up the rays from all 5 stars. But hey, maybe we would have been lucky and ended up on a planet where gravity and temperature changes wouldn't have bothered us so much. In that case, living in such a unique and inspiring environment doesn't sound too bad. It would have a great impact on our culture, arts, technology, and so on. With such a unique view of the cosmos, people would have a whole new canvas to work with. And just imagine, this isn't even the most complex of the systems we've discovered. For example, have you heard of AR Cassiopeia? It's a septuple star system, meaning it has 7 stars orbiting around each other. Now you might be thinking, wow, that must be a real chaos. And you're not wrong. Imagine trying to navigate a spaceship through all those gravitational fields. It's like playing a game of cosmic pinball. But all this serves as a reminder of the incredible diversity of the universe. Scientists continue to study and learn more about these rare and fascinating systems. And who knows what other mind-boggling star systems are out there, waiting to be discovered. Systems of 10, 15 stars. Nearly as many stars as there are in Hollywood. Get it? Stars, Hollywood? Okay, I agree, it's lame.
Tired of waiting for colonization? Does the Earth seem way too boring with all its problems and mosquitoes? Well, have no fear. It's time to take matters into your own hands and build your own planet. But before you start reaching for the cosmic glue and glitter, there are a few things you'll need to consider. Let's start our ultimate DIY project. First of all, we need to choose a location. Every planet has to orbit a star, right? In a cosmic buffet, every star has its own unique flavor. To keep things organized, astronomers use the so-called stellar classification system. The massive stars are the divas of the cosmos. They're huge, bright, and are always stealing the spotlight. But it's not all sunshine and rainbows. They have a short lifespan, burning out super fast, like a candle. They also have huge gravity, so be careful that your planet doesn't get sucked in. The dwarf stars, on the other hand, may be small, but they make up for it with their stamina. They can burn for trillions of years, which means that their planets have plenty of time to develop life. Super hot stars are blue or white ones, while the cold stars are usually red or orange. Yeah, seems like it should be the other way around, but we're not the ones making the rules. So what do we choose? Well, the planets around the blue and white stars could be scorched and fried, like a crispy chicken nugget. On the other hand, with cool red stars, our planet on to the next step. Ogres! Planets are like onions. They have layers. Most planets have three main layers: the core, the crust, and the mantle. The core is the filling, as we've already discussed. The mantle is like a hot and gooey layer of caramel between the crust and the core. And the crust is like a thin layer of icing on a planetary cake, covering its surface. But not all planets are built the same way. Because of that, we have tons of options. First up, we have the gas giants, the big boys of the universe. In our solar system, it's Jupiter and Saturn. They don't have a crust at all. They're basically huge balls of gas, like hydrogen and helium, hence the name. Next, we have the ice giants, like Uranus and Neptune. They're like younger, cooler siblings of gas giants. These planets don't really have a solid surface, but it's not pure gas either. They're made mostly of water, ammonia, and methane ice. There are also ocean worlds, and no, they aren't made of pure water. They do have some kind of solid surface, but it's located so deep, and the ocean on their surface is so huge that it kinda does look like a giant water drop. Finally, we have terrestrial planets, like the Earth. They're made mostly of rock and metal. These planets have a surface to stand on, and usually come with a cool mineral collection. And let's not forget about the dwarf planets, the small but mighty. Pluto is probably the most famous one, but there are others in our solar system: Eris, Ceres, Haumea, and so on. They're the scrappy underdogs of the planetary world, always trying to prove their worth, but never making it to full-fledged planets. Which type do you like the most? Gas giants are probably the coolest ones with their enormous sizes, crazy winds, and scary lightning. We also need to create an atmosphere. It's the outer layer of a planet that plays a huge role in its climate and weather. It's also the planet's ultimate protector. Did you know that 90 to 95% of meteors burn up in the Earth's atmosphere? Imagine what would happen if they didn't. Dense and hazy atmospheres, the ones you'll find on places like Venus, have thick layers of carbon dioxide and sulfuric acid. In other words, it's not a planet, but an oven. It's so hot that you could cook a pizza on its surface in no time and get cooked yourself. Next, we have thin and wispy atmospheres, like on Mars. The thin layer of carbon dioxide makes its surface pressure about 1% that of Earth's. On planets like these, you could fly like a superhero if you had a good enough jetpack. Then we have mixed atmospheres, like the one on Earth. The layers of nitrogen, oxygen, and other gases create the perfect conditions for life as we know it. It's also where we get to enjoy sunny days, rainbows, and of course, water. And last but not least, exotic atmospheres. You'll find them on planets like Neptune, where the layers of hydrogen, helium, and methane create a blue-colored world that looks like a giant marble. They're super weird and unusual, so just perfect for creative planet builders. Almost done. The final question is, would you like your planet to have life on it? In that case, there are some things you should consider. For example, it should be located in the habitable zone. This is the sweet spot around a star where conditions are just right for liquid water to exist on the surface. Make sure your planet isn't too close or too far from its star. And don't forget about the temperatures. For example, you'll want a good amount of oxygen for a planet to be nice and warm, but not too much that everything spontaneously combusts. Of course, we need some water, but not too much, and a stable climate. You don't want your planet to be going through extreme swings in temperature or moisture. That's a recipe for extinction, not evolution. Oh, and the orbit should be stable, so that there are no major astronomical events that could throw things off. As you can see, this type of planet is very picky. No wonder it's so hard to find extraterrestrial life. Anyway, now that we've finished messing around in the Planet Creation Editor, how do we even build it? Well, how about terraforming? It's when we deliberately alter a planet's atmosphere, temperature, and other conditions to make it habitable for humans and other Earth-based life forms. For example, we could release greenhouse gases on Mars to warm up the planet and create a thicker atmosphere. But this method is more like polishing a monstrosity that was given to you by a character randomizer. What about building from scratch? That's something straight out of sci-fi. But maybe in the future, we could do that, using large-scale 3D printing or nanotechnology. We could create the basic structure and then add all the necessary conditions for life to exist. Of course, all this is still purely theoretical. But while creating a planet artificially is still a long way off, there are many creative ideas and concepts being explored by scientists and sci-fi writers. Who knows what the future might hold for the possibility of creating new worlds?
Have you ever wondered what it would be like if every planet in our solar system was the size of Earth? Well, it's time to dive into this mind-boggling scenario. Let's imagine what each planet would look like if they were as big as our beloved blue planet. Would the barren red landscape of Mars suddenly become a lush green oasis? Would the massive swirling gas giant Jupiter just disappear? And how would it affect our solar system as a whole? Are we all doomed? Buckle up and let's find out. The first planet on our list is Mercury, the smallest planet in our solar system. But now, forget about the moon-like Mercury. Instead, picture yourself on the surface of a super dynamic incandescent inferno. There are a lot of craters and active volcanoes around you, and right in front of you is a huge, blinding bright sun. What a nightmare! But let's break these changes down. Well, along with the size of Mercury, both its mass and gravity would increase. In that case, it's possible that Mercury would have more atmosphere. Temperatures on Mercury are extreme, not only because it's very close to the sun, but also because of its very thin atmosphere. So during the day, the temperatures there reach 800 degrees Fahrenheit. And at night, it becomes terrifyingly cold, down to negative 290 degrees Fahrenheit. But now, when the gravity is stronger, Mercury could have a denser atmosphere, so the heat would be better distributed across the planet. And the atmosphere isn't the only thing that could make it hotter. If Mercury became bigger, it would likely experience increased internal heating due to gravitational compression. And hypothetically, its tectonic activity could increase. In other words, more interesting landscape, more mountains, and more scary active volcanoes. Congratulations, you've turned Mercury into Venus 2.0. For us, all these changes wouldn't be very pleasant. Now, it would become much harder to send our spacecraft there, so it's better for Mercury to stay as it is, small, calm, and boring. Basically, the complete opposite of our next planet, Venus. So what would happen to Venus if it was Earth-sized? Actually, nothing. It wouldn't change at all because Venus is already almost the size of Earth. It's even called the Earth's twin, although twin is a big word, of course. In reality, we couldn't be more different. Venus is often called the morning star because it's so bright and visible in the sky. But don't let its beauty fool you. This planet is one of the most inhospitable places in our solar system. Its surface is hotter than a freshly baked pizza, around 900 degrees Fahrenheit, and it's covered in thick clouds of sulfuric acid that would dissolve any human who tried to visit. So, unfortunately, you won't be planning any trips there anytime soon. So let's move on to a planet that, unlike Venus, could potentially become a new home for us, Mars. Picture yourself standing on Mars's surface, watching the blue sunset and breathing in a refreshing breeze of air. Yes, you read that right, air. Moreover, you could be surrounded by plants, animals, and basically feel like you're on Earth. But how is that possible? Bigger Mars would have a stronger magnetic field and gravity. This would lead to a richer and denser atmosphere. It would likely have a wider range of gases, including oxygen. Wouldn't that be cool? Also, a denser atmosphere could distribute heat across the planet, so Mars would become much warmer and cozier. And here comes the most important change: liquid water. Mars actually has some frozen water at its poles and in subsurface reservoirs. But with a stronger gravitational pull, it could potentially stabilize liquid water on its surface. Hooray! However, it's not all fun and games. New Mars would also have a volcanic personality. It's already geologically active, but now its internal heat and pressure would skyrocket. That means more frequent and more crazy volcanic eruptions. Imagine how exciting it would be to witness such eruptions on another planet, if you manage to escape the consequences. In general, the planet could become greener and lusher, but not safer, although it would still be great to see it. But it's time to move on to the giants of our solar system. And if we're enlarging the planets before, now it's time to squeeze them really, really hard. If Jupiter became 11 times smaller, oh boy, what a disaster that would be. The first thing we'd notice is a change in gravity. And I say we'd notice because now we'd have no choice but to move somewhere. Jupiter experiences from 30 to 100 collisions with large asteroids per year. No big deal. All because of its strongest gravity, which attracts them all and protects us. But now our big protective brother has turned into a small baby. Say hi to a bunch of asteroids. Oh, and say bye-bye to Jupiter. This planet is known for its thick, swirling atmosphere. But with a weaker gravitational pull, Jupiter would probably have a hard time holding on to it. So over time, it would slowly escape into space, leaving behind a thin atmosphere composed mainly of nitrogen and oxygen. We'll also have to bid farewell to the iconic appearance of another giant, Saturn. The most noticeable difference would be the disappearance of its famous rings. Made up of small particles of ice and rock, the rings are a unique feature of Saturn. But with Earth's gravity, they would either fall onto the planet or scatter into space. Bummer. Saturn is also a gas giant, just like Jupiter. Its atmosphere is made up of mostly hydrogen and helium. But if it were Earth-sized, its gases would be compressed due to the increased gravity. This would make it much denser. That means Saturn's overall size and shape would change. Theoretically, if we squeeze Saturn hard, it could potentially become a brown dwarf. It's a type of failed star that lacks the mass to sustain nuclear fusion, but emits heat and light. So, Saturn could stop being a planet altogether. The weather on it would probably have changed too. All its crazy storms, such as the famous hexagonal storm at its North Pole, would have become weaker and calmer. The next giant is Uranus. Let's try to compress this poor fella. First off, the surface gravity on Uranus would be much weaker than it is now. Its atmosphere might also change. If Uranus was smaller, it could have a thinner atmosphere and different gases altogether. This planet is pretty chilly, with an average temperature of -353 degrees Fahrenheit. Ugh. But if it was the size of Earth, it might actually warm up a bit due to its reduced volume to surface area ratio. Don't get too excited though, it would still be way colder than the coldest spots on Earth. As you can see, gas giants don't easily go through all this shrinking, except perhaps one of them. Surprisingly, small Neptune would become much friendlier. For starters, it would probably be a rocky planet with a tiny atmosphere. That means no more gas giant, but instead, a planet that's easier for humans and critters alike to live and move around on. Speaking of movement, because of the smaller size, the gravity on this new Neptune would be almost the same as Earth's, making it a heck of a lot easier to walk and jump around. No more floating away into space. Now, the atmosphere of the original Neptune is so thick you could barely see your hand in front of your face. And the surface pressure is about 100 times that of Earth's atmosphere. But our new Neptune would be much different, with a much thinner and less dense atmosphere. It would still have some methane, water, and ammonia in it, but nowhere near as much as before. Finally, the temperature. The current Neptune is freezing, with an average temperature of about -370 degrees Fahrenheit. But if it was the same size as Earth, it would likely be much warmer, just like Uranus. Ah, that's more like it. what a planet that would be. That's it for the changes in the planets. But what would happen to the entire solar system if we made all the planets so small? It's hard to predict, but it's clear that their gravity and orbits could change a lot. It's unlikely that any of them would have flown into outer space, or crashed into each other, or something like that. But many of their orbits would probably become quite unstable, and the number of collisions with asteroids would have increased significantly. Of course, all this is purely speculation. It's not like we can actually test all this, but it's still a pretty interesting thought experiment, and it makes you appreciate just how unique and special our solar system really is.
Here on our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in our cells. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Well, let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the United States in size. And all this amount of water would only be 0.02% of the total mass of Earth. So, it turns out that all these horrifying unexplored ocean depths are basically nothing. And now, just imagine if we changed the composition of our planet by leveling the volume of water and land. What would happen then? Then, we'd get a very creepy ocean planet. The planet would look like one boundless ocean. It'd be very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Well, maybe inside the ocean itself? Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down, not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice. But not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice 5, Ice 6, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at high temperatures. And there would be almost no algae or anything like that. So fish would simply have nothing to eat. That's why, if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes, but it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of the Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71 to 50%. In this case, the sea level would drop by about 2 miles, and a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. At first, it would seem pretty cool. Now, you could literally walk around the world. However, the amount of land you'd have to travel would also increase. every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, that would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat. But in places where there used to be deep oceans, you would see vast corridors and steep crevices. Now, here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them, but there would still be a lot of other cool places. For example, the ancient Roman city of Baia, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air, and since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? Now, to make matters worse, there would be nothing to extinguish these fires, because, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable, not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So, all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans, most likely, would make a big evolutionary step backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all of our might. Here's a random thought. Try to imagine the animals that could become the new top species should humans go extinct, that is. Tricky, right? I mean, we are pretty cool with our high intelligence, fashion sense, ability to cook, and smartphones, even if we forget the password sometimes. But if we suddenly disappeared, what animals might evolve to develop our skills and build complex societies like we have? Or would they come up with something better? Scientists have some ideas, thanks to modern gene sequencing technology and our understanding of evolution. We know that the climate on the planet will continue to change, so many species will need to adapt to survive. Convergence, which is when two unrelated organisms end up developing similar traits to succeed in a particular environment or fill a niche, will also play a big role. For example, fish are perfected for life in water with their torpedo-like bodies and fins. But dolphins have evolved a very similar body. even though they're warm-blooded, air-breathing mammals with a completely different evolutionary background. So, maybe some animals could develop hands similar to ours to fill the same role as humans, like building cities and modifying the environment. Primates like chimpanzees and bonobos are already close to that with their opposable thumbs, which they use to make tools in the wild. It's also possible that birds, the only surviving dinosaurs, could become the new smartest animals if humans suddenly disappear. Birds are incredibly brainy and can flock together in large groups. Some, such as sociable weavers, even build communal nesting sites, though they may not look like human metropolises. And let's not forget octopuses, which are probably the smartest non-human animals on Earth. They can learn to distinguish between real and virtual objects and engineer their environment. However, adapting to life on land might be tricky for them. You see, there's a lot we don't know about animal intelligence. And let's be honest, we humans have been quite arrogant about it throughout history. In the past, people used to think that animal intelligence could be neatly organized into a hierarchy, with humans at the top and insects at the bottom. But in the 1960s, a new generation of researchers challenged this idea and suggested that intelligence should be measured in relative rather than absolute terms. As technology has improved, we've been able to see animals for longer without disturbing them, and we've discovered they are far more intelligent than we once thought. For example, researchers in Melbourne are using remote-controlled drones to study the breeding patterns of southern right whales, and artificial intelligence is helping us track and predict the movements of all sorts of creatures. It's funny how we tend to recognize intelligence in animals when their behavior is similar to our own. Dolphins, for example, use names and even have accents. In fact, researchers have found that dolphins in southern Brazil have developed a distinct accent after interacting with local fishers for over 100 years. But it's not just mammals that are intelligent. Birds and insects are pretty smart too. Parrots, for example, have complex social groups and can differentiate between members of their species based on their relationships with each other. And even though their brains are tiny, like mine, insects are capable of some pretty impressive cognitive feats, like tool use and learning by observation. We used to think that intelligence was unique to humans and maybe a few other primates, but now we know that's not the case. In fact, research has shown that intelligence is distributed in different ways across the animal kingdom. Some animals excel in one area, but may not be as good in another. It's all about the environmental pressures that each species faces and how they adapt to them. We all know about the usual suspects when it comes to high intelligence in the animal kingdom: chimps, dogs, dolphins, blah blah blah. But there are some unexpected additions to the list that might surprise you. And you might even have one of them napping in your lap right now. I'm talking about our feline friends, house cats. They're renowned masters of getting treats and avoiding baths. But did you know they're also pretty smart? Cats have an amazing ability to learn from observation and repetition, which is why we've coined the term copycats. And some cats, like the one in this next story named Nora, take it to the next level. Nora's owner spends her days teaching kids to play piano, and this cat was getting a little jealous of all the attention they were receiving. So what did she do? She watched them closely, picked up on their movements, and started tapping away at the keys herself. And you know what? It worked. Nora's owner and the kids were amazed, and Nora became a little bit of a piano sensation. She even sits at the piano like a proper piano student. Just because she doesn't have opposable thumbs doesn't mean she can't be a musical prodigy, but wider paws would help to hit those octaves. The next story is about rats. Now don't jump on the couch in fear just yet. And before you go calling them pests, did you know that some rats are actually helping save lives? Researchers in Africa have been training these furry little detectives to sniff out lung disease in saliva samples, and they're really good at it too. These rats have a nose for the job and can detect different scents that are needed to show whether a sample contains a certain bacterium or not. Now, you might be wondering why rats were chosen for this important job. It's because they're super smart and quick learners. These rats go through a series of training exercises to learn how to sniff out different samples. They then alert their trainers to which samples hold bacteria. And get this, they can do it in just 7 minutes. a task that would take a human scientist a full day of testing. These rats can do in a fraction of the time. Dr. Rat. Ooh. Now, ever heard of Nellie the pig? She's surely not your average swine. This clever piggy has proved that animal intelligence goes way beyond just performing tricks. Nellie was presented with a series of challenges, including putting differently shaped items through a hoop. Now, while she was being taught to put round objects through a round hoop, Nellie decided to take it to the next level. When presented with objects that weren't round, she compared their shape with a hoop before deciding they wouldn't fit. This pig has some serious problem-solving skills. It's fascinating to see how pig brains process spatial awareness and solve different tasks. Who knew these curly-tailed creatures were such smarty-pants? Now, elephants are probably some of the most amazing animals on Earth, not just because of their looks. They are not only cute, but they're also super smart and empathetic. These gentle giants are known for their incredible cooperation and coordination skills, which they use to protect their families and scare away their enemies. In the wild, elephants travel in clans and communicate with each other using low-frequency rumbles. They work together to keep their young ones safe from predators, and they're not afraid to show their dominance by kidnapping calves from competing clans. Researchers have found out that elephants are quick learners and can work together to achieve a common goal. They even show empathy toward each other, which is a pretty rare feature in the animal kingdom. For instance, elephants have a special interest in the remains of their own kind. They'll linger near elephant bones and investigate sticks of ivory much longer than they would pieces of wood. Also, when an elephant is feeling upset, other elephants will come to comfort it by stroking its head with their trunks or even putting their trunk in its mouth. Now, how sweet is that? In 2010, one elephant in particular really impressed scientists with his skills. He was seen eyeing some tasty fruit just out of his trunk's reach. After pondering for a few days, he had his aha moment. He discovered a large plastic block and used it as a stepping stool to reach the fruit. He continued to use his newfound tool skills to reach even higher places, stacking blocks to get his favorite treats.
When you look at the night sky, it seems like there's not much happening up there, and that the stars always twinkle at the same spot. For thousands of years, researchers followed the idea that the lights in the sky were unchanging. Sailors guided their ships using fixed stellar patterns. There are also the exact outlines of constellations we observe today, and astronomers identified them a long time ago. It seems impossible that one day we wake up and simply can't see some stars anymore. Or does it? A team of researchers at Vanishing and Appearing Sources During a Century of Observations, or VASCO, studied the sky to check how things with the stars are going. The astronomers got the data from Gaia, the European Space Agency, and compared the information from 70 years ago to that from today to see how the sky has changed. To test it right, they had to use both modern and old telescopes. And something really interesting happened up there. Over 700 stars from the old maps were missing. If one star disappears, multiple theories could work. But it's harder when hundreds of them vanished at the same time. Could it be that the data was wrong, or these stars were too faint to detect? Nope, they quickly eliminated this option because these stars had clearly been part of their earlier observations. So, the first thing that comes to mind when talking about how stars disappear is that they reached the point where they ended their lives. You can have the most massive stars of all, and we're talking about those that are way heavier than our sun, and they go through sudden changes as they get to the end, which we also call a supernova. It's a powerful explosion that later shines for many, many months, and it's still visible even across hundreds of millions of light years. But that's the point. You see the traces, unlike here. Could this be a failed supernova? That means maybe one of them collapsed but turned into a black hole and consumed the remains from the inside out without causing a powerful explosion. But no one's been mentioning any signs of a black hole being active anywhere near those stars. And what if the stars had become less visible because of dust or gas around them? This is something that can easily happen, as interstellar dust and gas do block our view of objects that are far away. But there were no traces of unusually high concentrations of dust or gas. Nothing destroyed them either. Researchers would have seen traces if something like that had happened. Plus, these missing stars were not all in the same area, which means there probably wasn't just one fatal thing that made them all disappear. Also, the stars were not at the same stage of their life, so it's not an option they were all accidentally close to their end. They weren't particularly old or young, and they were on different levels in size and brightness. At some moments, it even seemed these stars haven't vanished because of some natural events. Maybe it was something related to other civilizations that might be somewhere out there in space. Maybe that's one of the ways to look for them. We could stumble upon some secret civilizations from other planets if we carefully observed the behaviors of stars, especially those we can't explain. No one knows what exactly happened with the missing stars, and unfortunately, right now, all we have are these theories. But you have to admit, they're cool though. Maybe it's just some kind of optical afterglow caused by gamma-ray bursts, or maybe even fast radio bursts. Fast radio bursts are powerful pulses of radio waves. They can release more energy in a couple of thousandths of a second than our giant sun does in almost 100 years. We don't really understand how these energy eruptions work yet, so we don't know what they can do. But still, hundreds of stars at approximately the same time. There are between 100 to 400 billion stars in our galaxy, so we'll probably see some of them disappear too. Hopefully, we'll understand better why such things can happen. Of course, scientists are not sure about this number because we can't see all of the Milky Way stars from our home planet. Some are too faint, some are too far, or even hidden by dust or gas. But they assume these numbers based on the size, shape, and likely mass of the Milky Way. And out of billions of stars, there are a little over 9,000 of them we can see with the naked eye. If you want to see more, you need a good telescope that will reveal those fainter ones your eyes are unable to discern. Many of the stars we see in the night sky are probably not alive anymore. Stars are giant balls of gas that produce light and heat through nuclear fusion in their cores. However, stars also have a limited lifespan, and eventually, they run out of fuel and stop shining. When a star passes, it can either become a white dwarf, neutron star, or black hole, depending on its size. Scientists have discovered that some of the stars we see in the night sky are too old to still be shining. This means that they may have faded, but we are still seeing their light because it takes so long to reach us. Actually, we may be looking at the past when we look up at the stars. Check out all of the stars you can see with your bare eyes. They lie within about 4,000 light years of us. That means what we're seeing are stars that appeared 4,000 years ago. Most of the stars we know of exist within galaxies, which are massive collections of stars, gas, and dust held together by gravity. Still, there are large areas of empty space between galaxies too. And the question is, could they have any stars? It seems that these areas of space are not completely empty. There is still some gas and dust, as well as dark matter, which is a type of matter that we cannot see but we know exists because of its gravitational effects on other objects. Scientists have even discovered a few isolated stars in these areas of space. These stars didn't form there. They ended up there by accident, which means they have probably been ejected from their galaxies by gravitational forces or collisions with other objects. And there could be more of these stars than we realize, but they are simply too dim to be seen from Earth. Stars don't actually twinkle. It's more that we just see it like that from the Earth. It seems like they twinkle because of the turbulent atmosphere of our planet. The light from a star must pass through many layers of the atmosphere. Not every layer is equally dense, so this causes the light to slightly deflect and change in color and intensity. There's one star named Sirius that sometimes twinkles, sparkles, and flashes so much that some people even tend to report it as something extraterrestrial. This is because Sirius is very bright and is often low on the horizon, which means it experiences more of these special effects of the Earth's atmosphere. When in space, astronomers and astronauts who observe stars from there don't see them twinkling. Hey, want to hear something cool? Me, you, your friends, the rest of humanity, we're all made of stardust. The elements that make up human bodies and all life on Earth were formed inside stars. The building blocks of life, such as carbon, nitrogen, and oxygen, were created inside stars and were eventually released into space when the stars were gone. These elements then became part of new stars, planets, and eventually life on Earth. The iron in our blood was created in the cores of supernovas, which are massive explosions that occur when stars fade. Some say that even the calcium in our teeth and bones is likely to come from exploding stars. The oxygen in our lungs was created in the cores of massive stars before being released into space through supernovas.
Imagine traveling to another planet on a journey that lasts for centuries, even millennia. Sounds crazy, right? Well, it might not be as far-fetched as you think. Scientists and engineers have been considering this possibility for a long time. And recently, a new study showed us how we can feed astronauts for as much as 6,300 years. Buckle up and let's find out what they learned. First of all, how do we feed people in space right now? Astronauts on the International Space Station, or ISS for short, can live there for several years. And they can't just pop out to grab a quick bite to eat. So what's the solution? Well, these astronauts have to rely on pre-packaged and dried food to keep them going. And no, they don't just eat astronaut ice cream all day, although that would be pretty cool. These meals are carefully planned for them to provide the nutrients and calories they need to maintain their health and perform their duties while in space. Currently, these astronauts consume about 4 pounds of packaged food per day. So the next time you get sick of your usual meals, remember that at least you're not eating the same thing for months on end in zero gravity. But these astronauts have been living in space for only a few years. Besides, they're still very close to our planet. Now, what about space adventures that last longer than your life? It's not as easy as packing a few ice cream sandwiches and calling it a day. Here, we face a number of problems. First challenge is the limited space available for food storage and production. Our regular methods of storing food, such as dried and packaged goods, aren't very practical for long-term space travel. Can you imagine how many jars we'll have to store to eat for centuries? Not to mention that after all these years, there won't be any vitamins in this food anymore. Another challenge is the limited resources available for growing and producing food. To survive on a closed spaceship, we need to recycle nutrients and resources like water and waste. So traditional methods of farming, such as using soil and large amounts of water, won't help us either. So what do we do? Don't worry, space pioneers, the answer might be space farming. That's right, folks, we're going to have to create a self-sustaining system. Astronauts of the future could be growing their own fresh foods, raising animals, and so on to feed themselves. We can also use traditional farming techniques to produce fish, dairy, and honey. Not only would this provide a yummy change from the usual dried space grub, but it would also help recycle nutrients, generate oxygen, and purify the air. Although there are still many challenges to be addressed, for example, how do we grow crops in microgravity? And how do we make sure the system stays self-sustaining over a long period of time? And most importantly, how can we fit it all in the cramped quarters of a spaceship? Actually, there's a possible solution for the last one. One way to maximize the use of space is through the use of aeroponics. This is a method of growing plants in which they can grow without soil. With the use of aeroponics, we can maximize the use of limited space. Pretty cool, right? As you can see, feeding astronauts isn't quite as simple as packing a lunch and heading out the door. But the good news is that we've already started testing these self-sustaining systems. There's a greenhouse in the ISS called LADA. It's been used to grow plants in microgravity since 2002. In this greenhouse, astronauts can grow fresh produce and herbs to mix things up a bit. Plus, it helps recycle nutrients and purify the air, helping to create a closed ecological system. It's basically like a little oasis in space. So right now, we're testing to see if this system could be used to sustain the crew on long journeys. Now, we know that the planets beyond the solar system are incredibly far away from us. So, how many years exactly would such a journey take? The closest exoplanet to us is called Proxima Centauri b. This exoplanet, or a planet outside our solar system, orbits the star Proxima Centauri. It's special, not only because it's just 4.2 light-years away from us, but also because it's located in the habitable zone of its star. In other words, it could potentially have conditions suitable for life. Scientists have even suggested that there could be liquid water on the surface of the planet, which, as we know, is a key ingredient for life. No wonder we want to visit this place one day. But the thing is, it would take about 6,300 years to get there with our current technology. So even though this planet is the closest one, this is a bit of a long flight. Not just a hop, skip, and a jump, you know? But let's imagine that we decided to go there now. We have thousands of years ahead of us. How will we evolve and survive in such a resource-limited environment? And, of course, how do we feed so many people since the ship is going to be multi-generational? That's the question that puzzled some European astronomers. Frédéric Marin, scientist at the Astronomical Observatory of Strasbourg in France, and his team decided to conduct a study on this topic. To answer our question, Marin and his colleagues used a numerical code called Heritage. And this is quite an interesting tool, the only one of its kind. This is a program code focused on multi-generational spaceships. It uses lots of scientific data and investigates their mathematical, biological, demographic, and statistical feasibility. Anyway, first, they calculated the annual caloric intake of the crew on board. Then, they compared it with our modern standards of agriculture. As a result, it turned out that in order to feed about 500 meat-eaters, we need about 0.2 square miles of farms. The study assumed that things like fruits, vegetables, starch, butter, and sugar would be produced by using aeroponics, which we talked about earlier. And ordinary farms will produce meat, fish, honey, and dairy products. And that's great! The results of this study are consistent with the forecasts of the Food and Agriculture Organization of the United Nations. Moreover, this is all taking into account aeroponics and microgravity. But some scientists believe that we'll need even less space. According to Mike Dixon, an independent researcher at the University of Guelph in Canada, previous studies have shown that if all these space travelers were vegetarian, they would only need about 8 square feet of land per person. This would include things like water recycling, oxygen production, and so on. So, if we cut out meat, we could take up less space and still maintain everything we need for life. This idea was picked up by Briardo Lorente, synthetic biologist at Macquarie University in Australia. He noted that in the future, we'll most likely grow food with the help of microbes. We're already gradually replacing animal meat products with microbe-produced foods. This way, we'll have delicious meat and won't have to bother with cattle. But the land area isn't the only problem that we'll have to face. For example, we know that plants grow slower in space. We can simulate things like light, temperature, and humidity, but gravity and radiation are much more complicated. We'll have to study these things for a long time to deal with them. Also, this new study doesn't address our most important problem, water. We more or less understand how to feed the astronauts, but what about drinking? We'll have to create a stable water circulation system inside the spacecraft. Marin and his team plan to address this issue in the future. They'll use the same code, Heritage, to find out how we can keep our entire crew hydrated for centuries. Anyway, it seems like intergalactic travels aren't as fantastic as they used to be. Of course, it will take years to make it a reality, but let's hope that one day we'll actually be able to grow tomatoes in the vastness of space. It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this: how did it form? The answer is nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view. These days, the atmosphere of the Moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the Moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the Moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.
Incredible news has recently spread across the internet. NASA has discovered evidence of a parallel universe. But is this actually the truth? Well, there is a grain of truth in this story, but it's not that simple. Let's consider it. Perhaps you've seen the articles that said NASA has finally found a parallel universe. The story was widely publicized, and people got divided into 2 camps: those who took this news at face value and those who considered it all complete nonsense. But both sides aren't exactly right. Let's start from the beginning. The discovery was made by NASA's ANITA. This name stands for the Antarctic Impulsive Transient Antenna. Yeah, it was designed to study neutrinos. Neutrinos are high-energy cosmic particles. They're incredibly small, lack any charge, and have almost no mass. Trillions of such particles pass through our bodies every second, and we don't even notice them. All because they almost don't affect ordinary matter. That's how insignificant they are. On average, in our entire life, each of us gets affected by a maximum of one neutrino. So basically, hunting neutrinos is like hunting ghosts. To catch them, you would have to send a whole stream of these particles through a giant piece of lead, and it has to be trillions of miles thick. At the same time, you have a 50-50 chance that you'll stop one of them. Therefore, in order to detect them, scientists had to come up with some clever tricks. We know that neutrinos, like other similar particles, come to us from outer space. Ooh. They travel to Earth from the Sun, stars, and even from the Big Bang itself. Some of them come to us from particularly big sources, such as black holes, supernova, pulsars, and even from various unidentified objects. Some of these particles have particularly high energy, and for scientists, these neutrinos are the most interesting ones. But oddly enough, most high-energy neutrinos don't actually come to us from afar. They form right here, next to Earth. This process has a cute name: particle shower. Well, this is how you can explain it in simple words. A granny particle gets into Earth's atmosphere. Usually it's a particle with very high energy. Then it generates several children that have less energy. Each of them then makes more grandchildren whose energy is even less than theirs, and so on, until we have a giant family tree of low-energy particles. In the end, there may be billions of them. During this process, piles of neutrinos are created. Then they begin to sink deep into our Earth. During their journey through the planet, they touch the upper layers of its crust or ice, for example, Antarctica's ice. When faced with all these obstacles, they create radio pulses, and as you might have guessed, these are the exact radio pulses that scientists are trying to find. It may be a surprise to you, but Antarctica is pretty deserted, you think? And that's why it's the best place to study microscopic particles, which usually can barely be traced. There won't be any interference or anything like that. We can catch these pulses with the help of powerful antennas. NASA places these antennas on balloons that can rise as much as 20 miles above Earth's surface. That's how they've been tracking these neutrinos for the past years. Alright, now we know what Anita is doing. But what about that parallel universe stuff? Nah, don't worry, we're getting there. In 2018, Anita began receiving abnormal radio signals that caused quite a stir in the scientific community. Remember how neutrinos come to us from outer space and then gradually sink deep into our planet? So, recently, Anita has discovered neutrinos that didn't descend from space as usual, but rather rose up from Earth. In other words, these particles, called tau neutrinos, basically travel back in time. But how is this possible? Scientists began to research them. At first, they thought that maybe it was a detector error or an error in interpreting the data. But no, everything was correct. Something very exotic was happening. If so, then first we must try to find a simple explanation. What if these tau neutrinos just came to Antarctica from some other source? Maybe they came to Earth from the other side and somehow passed through the boundary. To test this theory, scientists decided to seek help from another cool neutrino observatory called IceCube. Yes, very cool. This observatory is located near the South Pole. It consists of 5,160 optical detectors buried in ice, and all these powerful detectors are designed to detect neutrinos. Anita researchers were like, "Hey guys, we found some strange radio signals. Could you please check where they come from?" "No problem," IceCube replied, and started their research. And as a result, they found nothing. Yep, IceCube didn't detect any signal sources at all. It turned out that these strange particles had basically appeared out of nowhere. How could this be? Scientists tested many different theories, but none of them could explain the situation accurately. Later, IceCube published an article which basically said, "Nope, we have no idea where these signals came from and how to explain them in terms of the standard model of the universe." Oh, now it's getting interesting. So, what on earth are these signals? Having exhausted normal explanations, scientists began to consider ideas that go beyond our understanding. One of them said that perhaps these particles had come to us from a parallel universe where time flows in the opposite direction. This crazy-sounding theory is the result of the famous multiverse theory. According to it, about 14 billion years ago, when the Big Bang happened, two twin universes were born. One of them was ours, and the other was a parallel one. And they're almost identical in everything, except for some things. For example, time in this parallel universe doesn't move in the same way as it does in ours. It moves backward. Besides, everything there would look upside down to us, as if we're looking in a mirror. Therefore, scientists call it the antiverse, and believe it could be filled with antimatter. And even though all this may seem strange and crazy to us, for those who live in that antiverse, their way of life would be quite normal. In fact, they would rather find us, the strange ones. So these mysterious neutrinos could be born in this antiverse. Let's say they somehow existed there and then accidentally got into our world, where we were able to detect them. The idea of the multiverse itself is really incredible. If it's true, then it may mean that there is an infinite number of realities, many of which are much better than ours. Quantum mechanics even says that it's quite possible that every second of every day, any of your decisions divides the universe into two. And so there are quintillions of parallel universes where our lives have gone very differently. Something like this is hard to even imagine. Of course, it would be great if we could find a way to get into another universe, and if these mysterious tau neutrino particles were able to cross the boundaries of two worlds, well, maybe we can do that too? But unfortunately, this phenomenon alone isn't enough to say whether the multiverse theory is true or not. This is just one of several possible options. At this stage of human development, we cannot prove or disprove this theory. Maybe someday in the future we'll find out the truth, but definitely not now. The only thing we can say now, after this discovery, is that we've found strange radio signals which standard physics can't explain. So we need to move in this direction and study them to learn more about this incredible phenomenon. But people like to dream about space, so no wonder we've gotten so excited about this. And it would be great if one day it turned out that this theory was actually true. The theory of parallel universes has been popular in various movies and books for a very long time. Where would you go if you found out that you could travel between realities? Me? I'd look for a different reality of ice cream.
It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope. 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some superglue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, the other one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons 1, 2, 3, and 4. But let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So, these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the four. It's comparable in size to the moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in two ways. The first is through congelation, a rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into the freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd manage to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size, but having only half of its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited, it's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection, but because of its quirky tunes, Ganymede was soon nicknamed Jupiter's singing moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the furthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active, but scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features low levels of radiation. Given this suitable environment, we may one day end up setting a human base for future explorations here.
Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer, though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And, most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P/Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Sheqi and Wenxian Thungkao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets, in general, may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids, though. Unlike asteroids, which are small rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's Comet appears to have formed in the Oort cloud at the outer edges of the solar system. But Borrelly is said to come from an icy cloud of rocks beyond Neptune. which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.
So Mars has 2 moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its sons after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these 2 satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas. And these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile-wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen. So this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else, something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time, they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding.
There are almost no similarities between Earth and Jupiter. Ours is a sweet, small planet with plants and cute pandas. Jupiter is a giant gas horror with furious hurricanes which never subside. And if you fall into this planet, you might literally fly through it. But what would happen if our Earth was the size of the father of the solar system? Oh, this is going to be fun. Jupiter is a planet so big that I bet you can't even imagine its scale. Its radius is about 11 times the radius of Earth, and it's about 316 times more massive. So, to turn Earth into another Jupiter, we'd need to increase its radius by 11 times. If the planet's density remained the same, then the mass of our new Earth would increase greatly. Actually, it'd be as much as 4 times larger than Jupiter's. Of course, these changes wouldn't go smoothly. The very first thing that we would immediately notice, nope, not the size, gravity. It would increase by about 11 times compared to old Earth's. Scientists say we can actually survive on a planet with greater gravity, but only if it's less than 5 times stronger than what we have now. Well, let's assume that we're daredevils, always ready to challenge nature. What would our life be like? Well, not very pleasant. After each step, you'd have to sit down on a bench and take a break, as if you've just run a marathon. Yes, it would be that hard to walk. Oh, and good luck with getting up later. In order to somehow move around this planet, we'd have to pump up very strong muscles. No more problems with junk food, because you'd have to become a heavy lifter just to get to the refrigerator. The force of gravity affects not only movement, but also the size of everything. Do you know that many astronauts gain some height due to weightlessness in space? So if you're worried about being short, here's a solution for you. On the other hand, strong gravity would make us all shorter. This would go not only for humans, but for everything on our planet. Trees would become very small. To grow upward, they would have to move water from their roots to branches, which would be unrealistic with such gravity. So they'd all turn into little bushes. Also, no more mountains. Even the largest ones would become very small. But at least, now, everyone would be able to conquer Everest. This would also apply to animals. Our pets would have to quickly evolve into pumped-up corgis just to be able to walk somehow. Oh, and say goodbye to birds, of course. If you think that's not enough suffering, let's add another thing. It would be very difficult for us to breathe. Atmospheric pressure would increase dramatically. That's because Earth would start to pull air toward itself with great force. You'd literally feel the weight of it on your shoulders. Remember what I said about taking a break after each step? Now, imagine that you'd also have to breathe through a pillow. Yeah. And that's not all. Atmospheric pressure plays an important role in the behavior of water molecules. It would be much more difficult for water to boil or turn into ice. Most icebergs would melt, and it's possible that we'd have no more clouds, too. All water vapor would come crashing down on us in giant torrents of rain. We'd be lucky if we didn't get flooded instantly. But, oddly enough, there would also be some advantages. For example, everything around us would become much more spacious. Assuming we didn't get flooded, there would even be a bunch of deserted areas on the planet. Maybe land prices would finally fall. But these unexplored areas would most likely remain unexplored, since we'd hardly be able to travel across seas and oceans. Not only because moving across the water would be incredibly difficult, but also because all water bodies on the planet would become 10 times larger. The very thought of getting lost in the ocean is frightening, but imagine if it was 10 times deeper and bigger? Uh-oh. So, no more sailing. And forget about flying by plane or visiting space ever again. But it seems like it's still not all. If Earth was the size of Jupiter, we'd also have volcanoes raging everywhere. Due to the increase in its mass, Earth would become terribly unstable. All extinct volcanoes would become active again, and there would be lava and poisonous gases everywhere. In 1883, there was the most destructive eruption in the history of humankind, the eruption of the Krakatoa volcano. It occurred on one small island, but people all over the planet could feel the consequences. The eruption destroyed the island, triggered many tsunamis, and clouds of poisonous gases spread for miles. Now imagine this, but 10 times worse. That's what would happen on our Jupiter-sized Earth. It would probably be similar to the fall of the Chicxulub meteorite, the one that wiped dinosaurs off the face of the Earth. Then, poisonous gases spread all over the planet, causing one of the greatest massive extinctions in the history of Earth. Oh, and we would also lose the magnetic field, like the cherry on top of the cake. The magnetic field is very important for life on Earth. According to Rory Barnes from the University of Washington, it shields life on the planet from the nastiness of space, which means all sorts of radiation and solar winds. There's a molten iron core inside our planet that is responsible for producing the magnetic field. If the amount of pressure on this core increased due to gravity, it could solidify. And because of this, Earth's magnetic field would disappear. We would be exposed to the effects of cosmic radiation. Too scary to even imagine. Alright, so now we know that living on this new Earth would be a real nightmare. But what about outer space? You've probably heard that Jupiter, thanks to its strong gravity, protects us from asteroids. Well, this would become our job. Jupiter experiences about 24,000 collisions a year, and now it'd be our destiny. Do you remember me mentioning the Chicxulub meteorite? Similar tragedies happen to our planet once every 100 million years or so. But if it became the size of Jupiter, these guys would visit us every Friday. Also, we'd have to say bye-bye to the moon. Our natural satellite is too close to us. So if Earth grew in size, it would be a real catastrophe. We would literally watch the moon being torn apart in the sky. Of course, after that, all these fragments would crash into us. One of the theories claims that billions of years ago, the moon somehow separated from Earth, and its pieces gathered into a ball. Now, it would be like watching its creation rewind. And even if the moon survived, somehow remaining in Earth's orbit, the changes in the tides would still be dramatic. The consequences of these changes would be very unpredictable, but probably a bunch of tsunamis would be some of them. On the other hand, we'd probably gain a couple of new moons. Jupiter has as many as 79 of them. It would probably be a spectacular view, if only gas clouds from all those volcanic eruptions didn't block it. Also, the appearance of a second giant planet would have significant consequences for the whole solar system. Don't worry, other planets wouldn't crash into us. Many people underestimate just how far the planets are from one another. But still, the new Earth would shift the orbits of other planets a little and affect the rotation speed. And Earth itself would rotate around the Sun much more slowly because of its huge mass. For example, 1 year equals 12 Earth years on Jupiter. All this, of course, would greatly affect seasons and the climate in general. So, would there be life on Earth? Bold of you to even ask this question. But if one day we do manage to find a habitable super-Earth close to Jupiter in size, it would be very interesting to take a look at it.
It was January 7th in 1610 when Italian astronomer Galileo Galilei made an astonishing discovery using his homemade telescope. 4 moons orbiting the planet Jupiter. By the way, these days you can make your own version of his telescope using cardboard tubes, lenses, and some superglue. The main point of this DIY telescope is to place 2 lenses at the correct distance from each other. You'll need 2 lenses. One lens should be concave, the other one convex. So one lens is curved out and the other one is curved in. Galileo's initial telescope was able to magnify objects approximately 8 times. He continued to improve it until it reached about 20 times the magnifying power. But let's get back to the main story, shall we? When he first looked at those 4 moons of Jupiter, he believed he was simply looking at a bunch of stars. But he soon noticed that these space objects seemed to be moving in a regular pattern. It took him a couple of weeks to figure out that what he was looking at were not stars, but moons circling Jupiter. Galileo initially named those moons 1, 2, 3, and 4. But let's face it, those weren't the most creative names. As more moons in our galaxy were discovered later, the numerical system for naming them became confusing and impractical, so it lasted for just a few centuries. So, these days, those 4 satellites, Jupiter's largest, are named Io, Europa, Ganymede, and Callisto. They're collectively known as the Galilean moons to honor the man who first noticed them. Galileo's discovery was crucial for our later understanding of astronomy. It was initially believed that other objects revolved around the Earth since it was seen as the center of the universe. We now know that there are hundreds of moons in our solar system. However, large moons, like those discovered by Galileo Galilei, are not so commonly stumbled upon. A moon is considered large when it's the size of our planet or bigger. Ganymede, for instance, is bigger than Mercury. We basically call Ganymede a moon just because it orbits Jupiter. Otherwise, it has all the other characteristics of a planet. It's no surprise that Jupiter has the biggest moons in the area. It beats all the other planets in our solar system in both size and mass. So no wonder it pulled in a lot of other objects towards it. Jupiter is believed to have in total almost 80 moons, with only 53 of them being given official names until today. The first of those Jupiterian moons to be discovered by Galileo was Io. What sets it apart is the fact that it has a lot of volcanoes. Io is the only space object to have active volcanoes in our solar system, apart from Earth. It's also nicknamed the Moon of Fire and Ice because of its sulfur dioxide snowfields. Io's outer layer is splotchy, featuring multiple colors like orange, black, yellow, white, and red. That's probably the reason why NASA described it as a giant pizza covered with melted cheese and splotches of tomato and ripe olives. Because of that sulfur though, Io doesn't smell that appetizing, something similar to a rotten egg. There are more than 100 mountains on the surface of this moon. They are a lot larger than those we see on Earth, some being bigger than Mount Everest. On average, these mountains are 4 miles tall and 98 miles long. Because of those active volcanoes and the intense radiation on Io, there's little chance that life as we know it could exist here. But hey, who's to say it can't have life the way we don't know it? Next on the list of Galilean moons is Europa, the smallest of the 4. It's comparable in size to the Moon. Europa has an entirely icy surface, with just a bunch of craters scattered here and there. Because of that outer layer, Europa is very reflective, making it one of the brightest moons out there. As for its age, scientists believe its surface to be somewhere between 20 to 180 million years old. Europa is about 4.5 billion years old. What lies beneath that icy surface is impressive. It may even hold the secret to life outside Earth. Ice forms here in 2 ways. The first is through congelation. A rather self-explanatory process. Ice just grows as the surrounding environment gets colder and colder. The other method, though, is a lot more fascinating. A layer of supercooled water found under the ice shell reacts when agitated. It then generates these crystals that make it look like it's snowing in reverse, floating upwards to the ice sheet they sit under. You can recreate this environment yourself at home. Take a bottle of purified water and place it into the freezer. If you don't have purified water anywhere near, just boil some water a couple of times to get rid of as many impurities as possible. Since there won't be any particles inside, once in the freezer, it won't turn solid. But if you take the bottle out of the freezer and give it a shake, the impact will make the water rapidly crystallize, transforming it into a slush-like consistency. There may be water on Europa, but there's little evidence so far that life exists on this moon. However, it's one of the highest candidates in the solar system for potential habitability. Some sort of life forms could adapt to live there in its under-ice ocean. That environment is most likely similar to what we can find in our planet's hydrothermal vents hidden deep within our oceans. The amount of oxygen in Europa's atmosphere is very little, but in 2013, NASA gave away some cool evidence. This yet again supports the theory that there's potential for life on this moon. It seems that Europa might be venting water into space. If this is confirmed by future observations, it could also mean that Europa is geologically active. It could also come in handy if we'd manage to study water sources one day. The largest of those Galilean moons is Ganymede. It's also the biggest moon in our solar system altogether. It's a low-density space object similar to Mercury in size, but having only half of its mass. However, Ganymede is the only moon out there to feature its own magnetic field. It's quite small though, and we can barely notice it from Earth since it's overshadowed by Jupiter's much more powerful magnetic field. Another cool aspect of Ganymede is that its atmosphere contains oxygen. Don't get too excited, it's not nearly enough to support any life forms living there. Back in December 2021, a 50-second audio clip was released, which was previously recorded by NASA's probe on its Ganymede flyby. For the inexperienced, the sounds were more similar to those of an old dial-up internet connection, but because of its quirky tunes, Ganymede was soon nicknamed Jupiter's singing moon. Finishing up the list of Galilean moons is Callisto, or the most heavily cratered object in our solar system. What's interesting about this moon is that its landscape has barely changed since it formed, and scientists are still debating why this is happening. Most other space objects go through loads of changes throughout their lifetimes because of events such as collisions with other objects, changes in orientation or speed, or chemical reactions happening on their surface. Callisto is also about the size of the planet Mercury, but it has a lower density. Jupiter's magnetic field has a lesser impact here, since Callisto is the furthest from the giant planet. Its surface is estimated to be a staggering 4 billion years old. As opposed to Io, Callisto is not geologically active, but scientists believe there might be an ocean hiding underneath the moon's surface, which may potentially harbor life. The fact that it's less impacted by Jupiter's magnetic field means that it features low levels of radiation. Given this suitable environment, we may one day end up setting a human base for future explorations here.
We've been dreaming about life on Mars for a long time. Not only about growing potatoes there in the future, but also about all the potatoes that could have been there in the past. Has there ever been life on Mars? Recently, scientists have found something that could be evidence of that. Let's find out what happened. Mars is the fourth planet from the Sun. A human hasn't set foot on Mars yet, but robots have set their wheels. The first spacecraft that visited the red planet were NASA Viking landers. They flew there back in 1976 and sent us a lot of interesting data. Back then, we didn't know anything about Mars. To us, it looked like a cold, lifeless desert. But since we're so similar, scientists began to wonder, has it always been like this? Or is it possible that once Mars used to be thriving and full of life? And in 2022, NASA's Mars rover Perseverance found something that could shed a light on this mystery. But first of all, what is perseverance? Scientists have suggested that if there was life on Mars once, it's unlikely that it could simply disappear without a trace. It must have left some traces, perhaps underground, where they would be protected from radioactive solar tantrums and other nastiness. So we need to check the rocks. It's important to note that we aren't looking for life on Mars right now. There most likely isn't any. Instead, we want to look into the distant past of our twin planet. We're talking billions of years ago, when Mars could have been warm, green, and far from lifeless. In other words, we have to find dead microbes and various chemical compounds similar to ones on the Earth. This is the mission of our main character, Perseverance. It arrived on Mars in February of 2021. The spacecraft landed on the bottom of the 30-mile-wide Jezero crater, and after landing, it scooted over to the west, to the place that prompted scientists to choose Jezero for research. This place is a dried-up river delta, and this former river is already more than 3.5 billion years old. The Jezero crater itself was once a large lake. Yup, apparently there was life on Mars, and scientists have suggested that these places would be perfect as bodyguards of microbes. That's exactly what bacteria do on Earth. They hide, being still in the depths of lakes and ponds, so we could probably find traces there. The researchers believe that this particular lake has the highest scientific value in the entire mission. The highest chance to find rocks on which such bacteria could survive is here in Jezero. So Perseverance went to the delta. The row wasn't easy though. The rover missed a little and landed further than planned. As one famous movie said, "This little maneuver's going to cost us 51 years." Fortunately, Perseverance took only 1 year, and on the way, it was able to explore Jezero a little. The rover uses a complex built-in tool to explore the world. The tool is called Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals, or just SHERLOC. Boy, NASA sure loves its acronyms. As the device approached the delta, the signal of organic molecules became stronger. Soon, these signals were everywhere, and besides, they were the brightest that the scientists have ever seen. What does it mean? Elementary, my dear Watson. You know, Sherlock. It's time to dig. Since July 2021, Perseverance has drilled and collected 4 thin cores of sedimentary rock. The total number of collected rocks at the moment is 12. This is the first time in history that we're collecting something like this on another planet. These 4 cores were found on 2 rocks called Skinner Ridge and Wildcat Ridge. The first pair of cores, the ones from the Skinner Ridge, don't seem very interesting at first glance. They're quite close to what we can find in many places on Earth. However, if we look at them closer, we'll see that they're dotted with round grains of some dark material. These dark grains could have once been deposited on them by an ancient river, the same one that flowed into Jezero. It's possible that the river brought them from places hundreds of miles away from Jezero, and that's pretty cool. If we study these cores, we'll be able to learn even more about the far corners of Mars. Well, there are no corners on it, but you get the idea. Then, in April 2022, Perseverance did arrive at the delta, and then scientists finally found what they were looking for. The discovery, to put it mildly, excited them. They found 2 more cores, which held organic substances. This pair was taken from the Wildcat Ridge. It's found very close to the Skinner Ridge, but the 2 rocks are quite different from each other. These samples are lighter in color and more uniform. Most likely, they're mudstone, an unusual rock similar to clay, but harder and unable to absorb water. They're also finer grained than the cores of the Skinner Ridge. Why does it matter? Because the finer the grains in the stone, the more likely it is that there may be some traces of a past life in it. On Earth, fine-grained stones most often lie on the bottoms of ponds and in similar places. There, they can preserve the remains of dead organisms and similar stuff for years. And this is exactly what we found on them. Additionally, according to scientists, there was more organic matter in these 2 cores than in any other place studied by Perseverance so far. It probably accumulated there while the lake was gradually evaporating billions of years ago. So, there really was life on Mars? Well, let's slow down a little. Organic substances are molecules holding carbon. And yes, on Earth, they're most often associated with life, but not always. Sometimes they can form as a result of other things. Therefore, we cannot say for sure whether there was life on Mars. We don't know if these molecules really remain from some Martian microbes, or if they're the result of some other things. But the discovery is still very significant. We have to literally keep digging this way. To learn more about this organic matter, scientists need to collect a couple more samples of fine-grained rock. It would also be great to study the material lying around these former reservoirs. Perseverance has already moved to another area, to a place with a beautiful name, Enchanted Lake. Now it needs to look for similar things there. It will also continue to study Lake Jezero. Eventually, Perseverance will climb to the top of the delta and then continue exploring ancient sites outside the crater. Sometime before the end of 2022, Perseverance will probably have 6 or more samples of the Martian cores. Unfortunately, its tools, though complex, are quite limited. This data alone won't be enough for us to get a complete picture. Therefore, NASA plans to send other spacecraft to Jezero in the coming years. Together with the European Space Agency, they're working on the next robotic mission, known as the Mars Sample Return. The name speaks for itself. These devices will arrive and take away all the test tubes from the old Prospector Perseverance. After that, these samples will be delivered to Earth, though not by Amazon Prime, and then scientists will be able to analyze them in advanced laboratories. However, all this will take a really long time. The launch of this mission is scheduled for 2027-2028, and the spacecrafts won't be able to return until 2033. But if everything goes well, it will be the first samples in history delivered to Earth from Mars. In other words, there's still enough space for research, literally. And yes, we don't yet know the true meaning of these finds. But that's why the entire mission was created, right? And who knows? Maybe in a few years we'll finally find out the truth about what happened on Mars billions of years ago. Ooh, check out the Martian! Made you look. Look.
Have you ever wondered why rockets are launched right next to the equator or the sea? Or why do we launch them vertically and not like airplanes? Let's answer all the possible, not stupid questions about rockets. Question 1. How does the Earth affect the rocket's launch? Let's remember some school physics. The gravity of the Earth is incredibly strong. To overcome this force, we need to develop a huge speed. Fortunately, rockets are capable of developing it, but it would be much more difficult if the Earth itself didn't help it. The Earth rotates around the Sun at a speed of 67,000 miles per hour. Very fast, to put it mildly. And we are all moving with it. So getting off the Earth is like getting out of a moving car. For some time, the rocket will move along our planet by inertia. It's like a helpful push. The rocket takes off from Earth at a certain speed already, and then it just needs to accelerate a bit more with the help of its fuel. By the way, this isn't the only scientific trick in launching rockets. To get to the maximum benefit from this push, they're launched into Earth's orbit from west to east. Why? Because the Earth rotates from west to east, of course. This way, the rocket receives maximum inertia. Question 2. Why are rockets launched next to the equator? The answer is related to the previous question. Believe it or not, the Earth's surface is moving faster at the equator. The school lied to us a little. The Earth isn't perfectly round. Rather, it's a flattened ellipse. And the equator is the widest point on our planet. Now, what is speed? It's the distance divided by time. And since the distance at the equator is the largest, about 25,000 miles, then the rotation speed there will be higher. So, imagine that you and your friend were standing at 2 different points of the Earth. You are at the equator, and your friend is closer to the North Pole. After standing there for the entire day, you would fly more miles than your friend, which technically means that you moved faster. So yep, the rotation speed at the equator is higher. Naturally, it's most profitable for us to launch rockets from places where the initial thrust velocity will be as high as possible. And launching from the equator causes the spacecraft to move almost 300 miles per hour faster. Question 3. How do scientists choose the places for the launch pads? Rockets are gigantic, complex monsters weighing several thousand pounds. Needless to say, dozens of errors may occur during startup. Probably the most dangerous one is a mid-flight failure. That's when something goes wrong in a rocket that's still in the sky. If the burning debris falls to the Earth, it may cause a huge disaster. Now, let's look at a map of the location of launch pads in the world. You can see that many of them are located near the coast. For example, the Kennedy Space Center in Florida, USA, or the Satish Dhawan Space Center in Sriharikota, India. That's the way to minimize and ideally eliminate altogether the risk of debris falling on your head. If something goes wrong during the launch, it will fall into the ocean waters, far from densely populated areas. And yeah, there are a bunch of launch pads located far from the sea. That's because many other things also play a role in choosing the location. For example, the availability. The launch pad should be ideally accessible from land, air, and sea. Question 4. Wait, doesn't Florida have crazy weather? Why did they choose this state? For more than 70 years, NASA has been launching rockets from Cape Canaveral, Florida. It's because Florida has a very humid and tropical climate. There are more thunderstorms a year than in any other place. This can greatly interfere with rocket launches. It's very dangerous. Moreover, one time it actually happened. In 1987, lightning struck an AC-67 rocket before takeoff. Its systems failed and eventually the rocket was destroyed. Fortunately, there were no people on board. Another big weather threat is hurricanes. And yes, they also happen in Florida more often than in any other state. But despite all this, NASA still chose this cursed place to launch their rockets. Why? Well, probably because all the crazy things, including rocket launches, must happen in Florida. But on a serious note, before NASA moved to Cape Canaveral, rockets were launched from another place. From the White Sands test site, located in New Mexico. Back then, since White Sands was located in a remote area of the country, everything was more or less safe. If the rockets had fallen, they wouldn't affect or destroy anything. But as time went on, our technologies developed. The rockets got bigger and needed much more space for their launches. As a result, the danger zone also increased. White Sands was just 26 miles from Las Cruces, New Mexico, and 70 miles from El Paso, Texas. In other words, it was surrounded by settlements. Therefore, scientists began to look for safer places. The East Coast seemed like the best option. Can you guess why? Not only is the East Coast closer to the equator, but it's also located near the Atlantic Ocean. We already know that this actually adds +1 to the security. That's why in the 1950s, NASA moved its launches to Florida. The first one was the launch of the Bumper 8 rocket, which took place on July 24, 1950. And then, this place became a full-fledged spaceport. Question 5. Why are rockets launched vertically? Rockets are thin, cylindrical tall things that go into space vertically and leave behind a giant cloud of smoke. But why are they launched that way and not like airplanes, for example? Well, this sounds a bit crazy. To implement it, we'd have to make a lot of changes to the current rocket designs. But the most important thing is that it would waste a lot of resources. This may surprise you, but planes and rockets are designed a little differently. The plane's main task is to fly in the atmosphere. The rocket's main task is to leave the atmosphere as soon as possible. Due to the air resistance in the sky, the rocket loses most of its energy while flying. Therefore, we need to make sure that it has left the Earth's atmosphere before its fuel is completely used up. And since it needs a lot more fuel than an airplane, it's easier and more economical to launch it straight up. So it will use a minimum of fuel. Just what it takes to kick gravity in the face. Question 6. Why does the trajectory of a rocket change after launch? Remember that we said that the rocket's main task is to escape gravity by any means and reach space? Now forget about it. Technically it's true, but it doesn't show the full picture. The very task of getting into space isn't particularly difficult. The space isn't actually that high. You'll officially become an astronaut if you go to an altitude of about 60 miles above Earth. But it's all about staying in orbit. The orbit is the boundary of two worlds. Here, the gravitational pull of the Earth is still large enough that the rocket doesn't fly into outer space, but at the same time, low enough that it doesn't fall back to Earth. So, if you reach it, there's no need to waste fuel anymore. The spacecraft will simply fly in zero gravity by inertia. If the rocket flies purely in a straight line, it will simply fly into outer space. To enter orbit, it needs to fly in an arc. Therefore, after starting, it begins to tilt to the side and gradually increases this slope. Getting into orbit is a very difficult task actually. The fuel should be enough to reach an insane speed of 18,000 miles per hour. That's why we invented this optimization method. Smart people call it gravitational reversal. So a rocket bends its trajectory after launch because it has to go into Earth's orbit. Congrats, that was a long journey, but now you, hopefully, learned a bit more about rocket launching.
The Hubble Space Telescope was put into a low Earth orbit in 1990. If you think about it, it's had over 30 years of experience looking at various space objects. It was named after astronomer Edwin Hubble and was built by NASA. It is also part of a group of devices called NASA's Great Observatories, along with the Compton Gamma Ray Observatory, the Chandra X-ray Observatory, and the Spitzer Space Telescope. The Hubble Space Telescope was built to explore the universe and answer some of its biggest questions, such as how galaxies form and evolve, and how the universe itself has changed over time. The telescope has made many important discoveries, including providing evidence of the existence of dark matter and helping to determine the rate of expansion of the universe. One of the most famous images taken by the Hubble Space Telescope is the Pillars of Creation. It's a photo of a region of the Eagle Nebula, where new stars are born. The photo, which was taken in 1995, shows massive pillars of gas and dust towering above the nebula. It has become one of the most iconic images of the universe. The Hubble Space Telescope continues to operate and make important scientific discoveries, despite some initial technical difficulties. In 1993, a problem with the telescope's main mirror was discovered, which affected its ability to focus light properly. A repair mission was sent to the telescope in 1994 to fix the problem, and since then, the telescope has continued to work perfectly. One of the more interesting discoveries made by this amazing telescope is actually pretty recent. A report based on the data from the Hubble Space Telescope shows that there is a faint glow in space around the solar system that cannot be explained by anything we know to exist. Because they have yet to figure out the source, astronomers call this mysterious glow ghost light. We don't know that this light is not coming from the stars or galaxies near the solar system, nor is it coming from dust on the solar system's plane. The researchers aren't sure what the source of the light is, but they think it might be tiny particles of dust and ice left by comets. But it's only a theory that has not yet been confirmed. When we study the universe, we often find bright things like planets, stars, and galaxies. But from time to time, we discover some light coming from places where we didn't expect to see it, like from between planets. This light may be coming from deep within our solar system, and it may be a new phenomenon that hasn't been studied before. In other words, there may be something at the center of our galaxy that produces a lot of light. Spacecraft Voyager 1 also captured images showing a lot of light coming from the edge of our solar system. How come we haven't noticed this until now? Well, because most of the light in pictures taken by the Hubble telescope comes from things close to Earth. But people usually ignore this light because they're interested in things like stars and galaxies that are farther away. We've never actually looked closely at the amount of light in the universe and where it comes from. Scientists have been using the Hubble to find faint galaxies that may have been missed before and which may be the source of this dim glow. They found that there are not enough such galaxies to account for extra light in the sky. It's not a lot of light, though. It's like the glow from 10 fireflies. But it doesn't make it less important. It shows that we may be missing something. Let's look at some other important discoveries we've made with the help of Hubble. Like dark matter, which we can't see but know is there because of its effect on gravity. It makes up for about 23% of the universe. By looking at how it affects light, the Hubble telescope helped make 3D maps of where dark matter is. These maps show that dark matter seems to be getting clumpier over time, which means it behaves very similarly to how gravity does. The Hubble telescope also discovered 2 new moons around Pluto, named Nix and Hydra, and studied the dwarf planet's changing surface. Additionally, it's found the mass of planet Eris, which is larger than Pluto. This helps scientists realize there may be similar objects in the Kuiper Belt, a region outside our solar system. This led to Pluto being reclassified as a dwarf planet. Further observations of these distant objects could help us understand the evolution of our solar system. Gamma-ray bursts are the most powerful explosions in the universe, and for a long time, no one knew where they had been coming from. Hubble helped us find out that these bursts happen in galaxies, producing a lot of stars and having few heavy elements. This suggests that gamma-ray bursts happen when big stars collapse into black holes. These galaxies have lots of big stars that fall apart quickly, and the stars there don't have much heavy stuff, so they can turn into black holes. In 1994, the Shoemaker-Levy 9 comet collided with Jupiter. Hubble captured the whole event in detail, like a resourceful journalist. The impact broke the comet into a lot of small pieces, which resulted in 21 other visible collisions. The largest impact created a fireball and a dark spot on Jupiter's surface. Hubble's observations not only sparked public interest in cosmic impacts, but also provided new insights into Jupiter's atmosphere. To move forward with our list of discoveries made by the Hubble telescope, we also need to talk about black holes. There are points in space where gravity has so much force that even light cannot escape it. The gravity becomes so strong that matter gets squeezed into a very small space. We know that this can happen when a star, like the Sun, nears the end of its life. At the beginning of its life, a star's hydrogen ignites in its dense hot core. Because of gravity, it tries to draw its own mass into a tiny point. As long as it has the energy generated by the hydrogen fusion, it also pushes outward. If we look at it this way, the life of a star depends on a delicate balance between these forces, and it can last millions or even billions of years. Once that energy is exhausted, the only force remaining is that of gravity. So, some stars become black holes. Since light itself cannot escape its pull, we can't visualize black holes. For the human eye, they are invisible. We need special tools and unique telescopes to help us point them out in the universe. Hubble found that most galaxies with a central bulge of stars likely have supermassive black holes. It also noticed a strong connection between the size of these black holes and their host galaxies, which might help us understand how the universe has changed over time. Then, what is a supermassive black hole, you might ask? Go ahead, ask it. It is a very large black hole that is typically found at the center of a galaxy. It is millions or even billions of times more massive than our Sun. These black holes are so powerful that they can swallow stars and even entire galaxies. Scientists are still exploring these mysterious objects, but they believe that they play a crucial role in the formation and evolution of galaxies. Now, before Hubble, we really didn't know how old the universe was. It often led to weird paradoxes, like the one where stars discovered by astronomers were older than the universe itself. But by figuring out the approximate rate at which the universe is expanding, Hubble helped us narrow down its age, which is about 13.75 billion years. Trying to figure out the exact age of the universe is an important question. That's because most astronomers think that the universe has not existed forever, but appeared in one really hot and dense fireball called the Big Bang. I wasn't around then.
The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us. About 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust, rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system, and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future. I have a new recipe for you today. It's easy. You just have to follow 3 simple steps. First, you need to find one big star nearing the end of its life and heat it up until it explodes. That's called a supernova, the biggest and most powerful explosion we know about. It could take a while, maybe around 1 billion years, so you have to be patient. Step 2. As the core of this star is falling apart, stir all these electrons and protons until you mix them and turn them into a very dense soup. It's going to be hard, but you can't stop stirring. Toss in some gravity and apply as much as you think you need. So now you have some nice neutron stew. Crumple it to get an airtight sphere, approximately the size of Toronto. Cover the sphere with a crystalline crust, and it's almost done. Now you only need to serve it at about 1.08 million degrees Fahrenheit. This was a recipe for nuclear pasta. It's material that's 10 billion times stronger than steel. Talk about al dente, huh? No one can create something like that in a laboratory to really check how heavy and strong this material is. But computer simulations have shown it. Nuclear pasta could be one of the strongest materials in the universe in general. Neutrons inside the star are packed really densely, and the closer you get to the center, the denser it becomes. Neutrons get squeezed together and squished until they completely deform. Density there is more than 100 trillion times greater than the density of water. And the gravity is extremely strong too. On average, it's 200 billion times more powerful than the gravity on our planet. These crazy shapes that we call nuclear pasta are probably present only inside neutron stars. Their strong gravitational forces make their outer layers freeze solid, so they turn into a crust. But the insides are a liquid core. And there's also a fun party happening beneath the crust. Strong forces roil between the protons and neutrons and pull and push them in different ways. That means you can see all kinds of shapes below the surface. And scientists believe these shapes look a bit like pasta, for example, gnocchi and lasagna. These crazy shapes that we call nuclear pasta are probably present only inside neutron stars. It's incredibly strong, mostly because of its density. It's harder to break a coffee table than a cracker, right? How strong a material is going to be depends on its internal structure and how its atoms fit together. That's why some materials, such as chalk, are relatively weak because of all those holes. Diamonds are really strong since their atoms are well organized. Let's say you have a really massive star, like 8 times the mass of our sun. Bam! It collapses under the power of its own gravity. What's interesting is that a giant star can live for millions of years, but it can collapse within less than a second. And as a result, you get the whole mass of this giant star, but in a very compact core that's around 12 miles across. It would be like squishing the mass of 1.3 million Earths into one average American city. These are extreme conditions, and to be able to exist in such conditions, all matter inside a neutron star becomes way heavier than it would be in any other place in the universe. It's like having a single sugar cube that weighs over 1 billion tons, which is approximately the weight of Mount Everest. Neutron stars are also very hot. The temperature on their surface can go up to 1.8 million degrees Fahrenheit. For comparison, it's about 180 times hotter than the surface of our sun. And there are around 100 million neutron stars in our galaxy. We can spot them when they're relatively young. When they're not, they rotate really slowly. And they're also cold, which makes it hard to detect them. Neutrinos are very small particles that have almost no mass and travel at almost light speed. In only a couple of seconds after a star starts turning into a neutron star, the energy in neutrinos is the same as the total amount of light emitted by all of the stars we know about. Yeah, that's a lot. Listen up to this cool theory. If there was life on neutron stars, it could be two-dimensional, like in all those PC games that were popular in the 90s. Neutron stars are objects with some of the most powerful magnetic fields and gravity in the entire universe. The gravity is so incredibly strong there that it would probably flatten almost anything that ends up on the star's surface. Even the atmosphere would be different. Our home planet has an atmosphere that goes hundreds of miles into the sky. And since the gravitational force on a neutron star is so extreme, an atmosphere there could stretch for less than 1 foot. The fastest spinning neutron star that we know about rotates nearly 700 times in a second. And most of the neutron stars are probably pulsars, or they were at one point. A pulsar is a star that spins really fast, and while doing that, it spits out beams of radio waves. On Earth, it looks as if a giant lighthouse illuminates us. Because of their powerful fields, neutron stars can be dangerous for us too. If one got into our solar system, it would get chaotic. It could throw planets out of their orbits. If it got close enough to our planet, it could raise tides that would rip Earth apart. And what would be even more dangerous for us would be radiation generated by its magnetic field. Luckily, neutron stars are far away. The closest one is around 500 light-years away. There was an interesting case where scientists studied 2 neutron stars producing strong gravitational waves. 2 different stars here went through supernova explosions and left 2 extremely dense cores, neutron stars, behind. Scientists assumed these stars were going to merge, but they did something else instead. They were so close to each other that gravity pulled them together. They merged and created a black hole with one of the greatest mass we've ever found. Black holes and neutron stars have something in common. They both appear after stars finish existing, but black holes form when bigger stars explode. They're both extremely dense. You already know that not even light can escape a black hole because of its extreme gravity. Since they form in a similar way, some experts even say that neutron stars are failed black holes. Black holes are space objects that can create huge amounts of energy, although they don't produce any. But when 2 of them collide, there's more energy than all of the stars in the universe produce together. Black holes emit it in the form of gravitational waves. Most galaxies have one supermassive black hole in their center. Some of them are active, which means they shoot jets of different materials out of their centers. But most of them are quiet, sort of hibernating and waiting for some space object to come closer to feed on, like some hungry predator lurking in the darkness. So if you dropped something, let's say your keys, into a black hole, it would pull it inside before you even realize what's happening. Its extreme gravitational pull actually warps up space and slows down time. It would tug the keys closer and closer. After a while, they would go through an accretion disk surrounding the hole. This disk consists of space materials like gases, dust, and even rocks that circle inward around something we call the event horizon, which is basically the point of no return. Once your keys got inside, there's no chance you would get them back. They would probably end up being super stretched, or as science says it, spaghettified. A lot of things today are about food. I'm really getting hungry here. At the center of the black hole, there's a tiny point with enormous mass where density and gravity become infinite. It means time and space are different there than on Earth. Kinda distorted. At least, that's what we can assume.
Space travel has come a long way since Sputnik was launched into orbit in 1957. Since then, we've sent humans to the moon, set up the International Space Station, and even sent robot spacecrafts to explore other planets. But there's still lots more to discover and achieve in space. So, what are our current plans? What technologies are we developing now? And what awaits humanity in the next 100 years? Let's find out, shall we? First of all, artificial intelligence. Fun fact, my high school history teacher claimed this is what I had as per my test scores. Right now, humanity is actively engaged in the development of artificial intelligence, and we've already made a bunch of breakthroughs in this area. With the help of AI, we're going to be able to explore the cosmos like never before. Think about it. AI can automate and optimize tasks like mission planning and data analysis. Now, human astronauts can focus on more important things, like looking for some non-human astronauts. Plus, AI can control and operate spacecraft remotely, reducing the need for risky human missions. And that's not all. This super smart technology can also provide unique perspectives and insights that humans might have missed. AI could also help us understand the data collected by space probes. In short, the use of AI in space exploration will help us learn more about the cosmos and make exploration more efficient and cost-effective. And this isn't the only thing that will help us in conquering space. Next, reusable rockets. Gone are the days of one-time use rockets. These days, reusable rockets are taking over the space industry. Not only do they save money, but they also make space travel more accessible to a wider range of people and organizations. To date, the SpaceX company has created a bunch of reusable rockets, like the Falcon 9 and Falcon Heavy. They've completed many successful missions to the International Space Station and beyond. Blue Origin has also made great progress in reusable rocket technology with the New Shepard. It's even planning to take paying customers on trips to space soon. Alright, so these cool technologies will help us get up there. But what are we going to do next? Moving on to building settlements beyond Earth. Space colonization, here we come. The possibility of establishing colonies on other planets, such as Mars, is a dream that has captivated humans for decades, and now it's finally within reach. But before we start packing our bags, here are a few obstacles we need to overcome. For starters, getting to Mars is no easy feat. It's a long journey that could take months, if not years. So first, we need to figure out how to keep humans alive and healthy during the trip. Now, once we get there, we'll face even more challenges. The harsh radiation and extreme temperature fluctuations are just a couple examples. Living and working in space isn't easy either. We need to make sure that everyone has what they need to survive. It's not like you can just go to the store for supplies. So we'll have to build systems to provide food and water, create some advanced transportation, and maintain all of that in good condition somehow. Finally, let's not forget about the most important thing: money. Building and maintaining a settlement beyond Earth is no small feat, and it will take a lot of resources and cooperation to make it happen. But there are still great benefits in living in space. It opens up many opportunities for scientific research and exploration. We'll be able to learn more about the universe and our place in it. So, no dream too big. Even though it's a big challenge, it has the potential to be really rewarding for humanity. That's why private companies and space agencies are already working on plans to send humans to Mars and potentially even terraform the planet. Actually, let's talk about that. Terraforming. The dream of turning a barren, inhospitable planet into a habitable paradise. Sounds like something straight out of a sci-fi novel, right? Well, believe it or not, by using advanced technology and resources, we could potentially turn deserts like Mars into beautiful Earth-like worlds. But here we also have a few hurdles to jump through first. Terraforming isn't exactly a quick process. It would take lots of time and resources to make any significant changes to a planet. There are also some ethical dilemmas to think about. If we start trying to change the Martian ecosystem, we could potentially wipe out any existing life forms. Imagine if someone did that to us. Actually, we've been doing it to ourselves. And finally, there's the cost. Terraforming would be a major expense, and it's not clear who would foot the bill. It would likely require the cooperation of multiple countries and organizations. But even with all these challenges, this is still an exciting prospect. Who knows? Maybe one day we'll be able to turn Mars into the ultimate vacation spot. And that's just the beginning, because we won't stop at Mars. Our next goal is asteroids and other celestial bodies. Now picture this: you're floating in your spacesuit, mining an asteroid for some seriously valuable resources. You strike gold, or rather a shiny vein of platinum, and head back to Earth to sell it for a fortune. And with the money, you fund even more space mining expeditions, becoming the ultimate space tycoon. But seriously, space mining could be a game changer for space exploration and the economy. Imagine being able to extract water from asteroids to sustain human settlements on other planets, or mining rare minerals to use in high-tech industries back on Earth. The economic benefits could be massive. Of course, there are also challenges to overcome. We'll need to figure out how to safely and sustainably extract resources from asteroids. We also need to make sure that space mining is done in an ethical and fair way. But once we deal with all this, it'll change our lives forever. So let's get to work. But once we've mined everything, what awaits us next? For example, what lies beyond our solar system? Interstellar travel and the search for life. We've already made some amazing discoveries in our hunt for extraterrestrial life. For example, NASA's Viking landers and the Galileo spacecraft have given us some clues about it. Also, in 2022, we found traces of organic matter in the former Martian lakes. We're not sure yet, but perhaps Mars was once as prosperous as Earth. But we all know that the real excitement lies beyond our solar system. Scientists have already found thousands of other distant exoplanets, and some of them are in their star's habitable zone, meaning they could potentially support life. So our next step is to send probes or even humans there. Imagine being the first person to set foot on another planet, discovering microbial life, or maybe even a more advanced civilization. Talk about out of this world. And maybe, one day, traveling to another star system will be like a regular road trip, except instead of a minivan, you're in a spaceship. And instead of stopping at a rest stop, you're stopping at a new planet. Sounds awesome, doesn't it? Right now, there are a few ideas about how we might make interstellar travel a reality. One possibility is the use of wormholes. These hypothetical tunnels in space-time could potentially allow us to travel vast distances in a shorter amount of time. It's like taking a shortcut, except instead of cutting through someone's backyard, you're cutting through the fabric of the universe. Pretty crazy, huh? Another option is antimatter propulsion. This involves using antimatter, which is the opposite charge of our regular matter, as fuel for a spacecraft. When it comes into contact with regular matter, it releases a huge amount of energy. Imagine your car's gas tank being filled with antimatter instead of gasoline. That's going to be a powerful ride for sure. Of course, there are still lots of challenges to overcome before we can make interstellar travel a reality. But let's hope that one day we'll all be able to pack our bags and hop on a spaceship for a trip to the stars. Anyway, the future of space travel is looking bright. With all of these advancements in technology, we're excited to see what feats of exploration